Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. In this episode, we have an XSS on League of Legends, a post on car hacking and some serious fails in Hyundai, and a Grafana RCE and some other various things mixed in there. Before that, though, just want to note that next week, December 12th and 13th, will be our last podcast episodes for the year before we go on our Christmas break, and we'll be returning on January 9th and 10th. So did just want to bring that up, make anyone aware it wasn't around last week when I announced that. And yeah, with that out of the way, we can jump into our first topic, which is a bit of an old topic. The Humble Bundle deal that we talked about last binary episode. We didn't bring it up on the bounty side, and Z wanted to get into that. So yeah, we're bringing it up again, and I'll let Z take the lead here.
Yeah, I'm not sure this even was up yet for us to cover it on the bounty side, or it might have just been that morning before the episode. So yeah, I talked briefly about a couple of the books that were interesting, a bit more on the binary side from this bundle. Um, on the bounty side, and you have hacking APIs. I haven't read the book, but I have basically only been hearing good things about this book. It kind of tackles that ground between, like, a lot of web applications these days will just have a front end that communicates over an API. It kind of tackles that middle ground between web hacks and like web attacks and API specific things. Like, there's a huge overlap there, but there are some distinct things. Kind of plays around in that middle area a bit, which is really nice to see. uh Bug Bounty Bootcamp, not familiar with it, so I don't really have any strong recommendation there, but it is a no Starch press book. I'd assume it's at least decent, but the hacking APIs one solid. Ethical Hacking was a book that surprised me. I talked about this last time or last year around this time when we talked about their bundle. It's just a bit broader than I would have expected. Ethical hacking, I kind of expected to go into like network security and pen testing. It actually does spend a good chunk of time on like application security, on fuzzing, on bit of VR stuff. It's very surface level, so it's not like really deep or anything, but it was more broad than I was expecting, which was nice to see. Black Hat Python, always a fan favorite. Not my personal preference, but people seem to like the book. It's an option for learning Python, or at least having some project ideas to play around with in Python. Um, but yeah, I mean, there's a few books here, some to take a look at if you're interested. There's a good bundle. No Starch is generally a pretty good publisher. I generally don't have many issues with their books, though. I'll admit there are a few books here that are a bit gimmicky, or I guess I'd say. But yeah, want to at least shout out the bundle. It's available. You can take a look.
All right, so we'll get into our first exploit related topic, which is by Portswigger, and it's on hacking service workers via DOM clobbering. So yeah, it's a bit interesting when it's talking about service workers. If you're not familiar, they're they're basically like workers that can run to provide caching and offline stuff, which Portswigger goes into. Z, I'll let you talk this one through.
Yeah, I mean, they can run arbitrary JavaScript in the background. You'd set them up to run on specific events. That said, what's interesting about this is more of the DOM clobbering aspect. I think the whole ability to hijack a service worker, it's interesting, but it does seem like a pretty rare occurrence where you'd have this sort of setup. So what this application, we don't know what the application was that he actually found this issue on. But what it was doing was it would have this it would have a div inside of it called CDN, or with the ID CDN domain. And it would use that div to kind of pass around, well, the CDN domain, a domain that would end up being used by the service worker. The kind of path here is you'd have this div, ID, CDN domain, you'd have text side there representing the domain, and then some JavaScript would run, and when it registered service worker, it would generate that service worker URL. I pulled up here, and it would use, not the right example that I wanted, but either way, it would register the service worker URL, and it would include a host URL parameter in that service, in like the URL for it. based off of what it read out of that ID. So you have the case where if you can using DOM clobbering, if you can clobber that same CDN domain, you would be able to control the host from which it would try and import the service work would try and import all its scripts. It's a kind of a weird setup. I haven't really seen that before. Doesn't mean it doesn't happen, just my personal experience. I don't see that a lot. I would usually see if there is going to be that sort of injection, it would be injected, say, right into the JavaScript somewhere. Not doing it through like a random div that gets included and then it reads a div. I completely believe someone somewhere is doing this. It just doesn't seem that common to me to actually see that sort of setup. Um, but anyway, if you could do the DOM clobbering, and for a DOM clobbering attack, you do already need to have some sort of injection on the page. Because the idea is if you can inject like another DOM with the same ID, when it does this get element by ID, it's only going to return one element back. And so you're going to hope it's your element instead of the one they actually trust or want to have included there. And that's where I think the more interesting part of this comes off, because they do point out a couple cases where you can clobber the get element by ID without actually to have your DOM or your injected element first. Because usually you would want to have that element show up first. And 1 second, I think there are going to be some audio issues of Spectre. We're going to try and talk. I just need a moment.
I was
Now
gonna
we're good.
say, like, yeah,
Sorry.
I'll take the opportunity to ask, like, I don't really have much experience with DOM clobbering. I've never really tried it, and so I was about to ask, like, is there some sort of ordering guarantees with get element by ID that you're aware of, like how the hierarchy works in the engine, I guess. It's not really something I've thought about or had to think about, but
My
maybe this post
understanding,
gets into that a little bit.
it doesn't really. They talk basically with the same assumption or same understanding that I've had, which is effectively you need to be first. Whoever's earlier in the tree gets it. So basically, if I had to imagine how the code's written, I have not looked at that. It's probably just scanning over, and the first one it runs across is the first one that it gives it to. If it's looking for the IDs, so look or go over the tree, find the ID, and return it. Not really looking any deeper. So you just need to be first, higher up on the page, effectively. That said, I'm saying that, but there must be something more complex because they do call out if you can inject the HTML tag into your page, then that'll actually take precedence. So even if it's later, you'll actually be able to clobber it. So they have the example here of a div and then the HTML tag comes after it, but the HTML tag still ends up taking precedence. They called it out as working with the body tag also. And then they also point out how you can do this inside of SVG. So SVG body or SVG for an element, and then the HTML tags, effectively
It
getting the injections there. But these are places where you can inject it later, and that seems like the more interesting, or at least the takeaway here to me.
it kind of makes sense that the tag, like those higher level tags, would take precedence in like the DOM ordering. I can see how that makes sense.
Yeah, and they call this out as being something you can clobber against query selector also. Use query selector instead of query selector all. It again returns just presumably the first element, and you can still clobber the classes. Usually, query selectors use the query by classes. It could be more complex than that, but you get a lot more of a query sort of syntax for that. Um, Nonetheless, they mentioned using HTML body. So those are the two big takeaways that I'm getting from this post. The service worker attack there, that just seems a little bit unlikely. If it's there, great, but it doesn't seem like the most common setup to read that out of the DOM by ID and pass it in. Maybe I'd be surprised by that, uh, like by how common that is, but yeah, I'd say the main takeaway is really just the fact that you can still clobber after the fact. It does require that fairly privileged situation where you are able to inject DOM elements. That's it. I feel like DOM clobbering, it's a pretty old attack. I remember being talked about, long time ago. It's been around, so it's not like a new attack. I feel like, as cores, maybe as they get like stronger or get used more often with, properly written cores policies, DOM clobbering is a place where you can still get some sort of injection, get some sort of JavaScript running, um, and be able to bypass any sort of cores policy because you're not injecting an actual script. It's just one of those places that maybe in the future, as time goes on, we'll actually see DOM clobbering becoming a little bit more important with the like full exploit chain on the web. Right now, I really don't see it talked about too much, and even this simple thing, being able to use HTML or body, maybe that's well known. I just didn't know about it. Was a little bit surprising or at least novel to me, so I want to call it out here.
Yeah, I mean, as always, some interesting research coming out of Portswigger that's looking at something that doesn't have a ton of eyes on it, uh, and could become more important going into the future. So yeah, it's always nice to cover the Portswigger posts when they come up. All right, so up next we have a HackerOne report on an RCE in Grafana through SMTP server parameter injection, more specifically a CRLF injection in the password configuration setting of the SMTP server, as well as the username and from name parameters, which are mentioned a bit later on in the report. And yeah, fairly quick issue for this one. It was possible to inject new lines and subsequently set non-exported configuration variables that are passed through to the Grafana image renderer, which can include the rendering args, which they state can lead to code execution. And yeah, it led to a fairly significant bounty at $5,000 and got a critical rating. Bit interesting here in the way that I think you would need an existing token and some authentication to be able to set the SMTP server config. That's not typically something that's like, uh, like any untrusted person can set. So I was a little bit surprised that they paid that high, to be honest. But nonetheless, a decent bounty for a pretty common issue of new line injection. And yeah, I just wanted to throw it in there because it's, something we like to cover when it pops up as like a fairly trivial vuln and like a pretty big piece of software. And yeah,
The
I mean, nice
issue
bounty of it.
the issue itself is trivial, and that's just the new line injection, but finding it, I think, is a little bit more tricky because of just the route that you go to this. This isn't something where you'd have been able to just source the sync it and well, I guess if you had the file as like an untrusted source, you might be able to pull that out, but then you'd still need to find the way to modify the file and do this. Like you wouldn't find this vulnerability exactly. Using a lot of static analysis wouldn't really pull this up. It could pull up the perhaps for the new line injection. But like if you're testing for RC, maybe you have some hooks to see what commands are being run as you use the application. In that case, you wouldn't really have this flow up because you have to get the exploit correct in order to get really anything to happen. You have to specifically go and mess with the image renderer settings, inject that, go through render arcs, and get that all correct in order to actually exploit this. So like testing it is a little bit like you have to be aware of everything going on and see the file right and then what you can do from there. It is still something like, a new line injection is something to test for, and you can look that and see that. So it's not that difficult, but it is interesting to see it being pulled out here with that damage, just because of that knowledge kind of required on it. Just a fun little bug, really, too. You do have, in a sense, it's kind of getting to the second order attack where you have your first order is just writing it into the file, something else goes and trusts that file later. So yeah, nice attack. In terms of the payout and severity of it, because you are going from just a user or even an admin being able to do some of the configuration here on the system to having code execution within their one of their cloud systems, that is a step up. They don't expect you to have code execution on their system. So I can understand giving a higher rating to this.
Yeah, fair point, I guess. When it comes to cloud, there's a bit more of like a privilege separation than we see on a lot of other similar topics. So
I mean, even if it wasn't in the cloud, even if this was just the case of, a self-hosted instance, it's still a case of going from your user with access to code execution on the system. Like that is still a step up in privilege and a considerable step up.
Well, typically though, it like it's not really seen that way, right? Like you'll have like an admin panel that gives you the ability to run code as part of like the admin suite or whatever. Typically, it's not really seen as much of a security boundary in like non-cloud setups, but yeah, I mean you're still
It
technically
still
correct. Like it
is.
is it is giving you an escalation regardless. Yeah.
Yeah, because I mean, there are users of a system that are meant to be able to run code. Sometimes it is the case. And I feel like this is less common these days than it was like 10 years ago, where you'd have the admin area just letting you run code. Grafana is not one of those cases where the admin area, as far as I'm aware, can just run code. So at the
Yeah.
very least, in this context, you're not expected to be able to just run code. Um, Even on general self-hosted things, I don't see that as a feature very often anymore. Perhaps that's just I'm choosing to run better software, or perhaps that is the case. There's just less software that is doing those obviously insecure things. I
All
don't
right.
have the stats to know either way.
Yeah. All right, so speaking of privilege escalations, we'll get into our next topic here, which is a seclist advisory on a race condition in snap-confine, which is a SUID root binary that's installed by default on Ubuntu. And this bug was in the must mkdir and open with perms function. So as you can imagine by the function name, this is a helper function that's responsible for making a directory and opening it. But the thing is, if the directory already exists, so long as the directory doesn't belong to root, it gets renamed to a random directory in temp and it tries to recreate the directory again. So you can probably see where this is going. Ultimately, you can get a directory that you don't own renamed, and you can potentially race that to get snap-confined to use a directory you control for its operations, which you can symlink off to somewhere else to get a root file right. Now they go into a bit more detail on how this works and their like overall strategy. Yeah, so they down here where it says the three key ideas. Um, and yeah, so it basically involves running two instances of snap-confine running in parallel. So you can run one instance, block it after it creates its root directory, run another instance with an instance name that collides with the temporary name of the first,
Do you know
kill
how
the
they can
second
block
instance.
it? Sorry, they just say
Yeah.
block it. What are they doing there?
So they talk about they don't really go into detail on it on this advisory. They kind of link off to another one, but they talk about doing like a single stepping technique. I'm not totally sure how that works. I didn't look into it a lot. Um, but yeah, they seem to be able to like single step through snap confine, sort of like a GDB scenario. So you can like block it at certain stages.
Yeah, I
I
saw that. I didn't go look at their Lemmings advisory. They do that a couple times here where they're just go refer to or other write up, and I didn't have an immediate link to it, so I didn't end up
yeah.
doing that. But all right, yeah, that's kind of where I stopped to. Was I saw they did this through some method, but I don't actually have the method they used.
Yeah. So they can run one instance, block it after it creates the root directory, run another instance with the name that collides with the temporary name of the first, and then kill the second instance immediately after it renames the directory, which then allows you to manually recreate that directory and resume execution of the first snap confine. So when that first snap confine resumes, it'll read the tempter inside of that root directory you now own and control, and it will follow the symlinks. They did have some problems they had to overcome to exploit this, though. For one thing, it was difficult to get the symlink followed by snap-confine because the function that would mount the namespace bind mounts a read-only squashfs into the root directory. So you're kind of in this catch-22 where it's like if you create the symlink before the bind mount, it gets covered over by the squashfs, and then if you and you can't create it afterwards because it's a read-only file system. The way they got around that was by mounting a fuse file system onto root immediately when creating it. This was kind of interesting, and I never seen this mentioned anywhere else. But with the fuse file system, you can basically unmount any subsequent bind mounts. So in this case, they could unmount the squashfs basically right after it was mounted through fuse. Um, so yeah, I thought that was a pretty cool trick. The other problem they had was Snap Confine used App Armor, which would prevent bind mounting temp onto an arbitrary directory on the system. For that, they had to use a pre-existing vuln in multipathd, which gave the ability to basically create a root directory named failed WWIDs anywhere on the system. And they essentially turned that into an app armor bypass. This is another cool trick that I liked. They don't go into a ton of detail on it, but what I believe they do here is they use that ability to create a like limited name directory to create an app armor policy namespace, and then they just set that namespace to be able to do whatever they want. So yeah, basically creating their own namespace through app armor that they can laterally move into to be able to bypass app armor. So then they were able to exploit the bind mount against the multipath lib. They figured they're using multipath for bypassing app armor anyway, so might as well attack it. So yeah, they attack the multipath library directory, create their own shared library, and then get multipath restarted to get their library ran as root. So it's a pretty complex like chain and how it works. They had some various problems to overcome, and like Z said, unfortunately, there is some like missing info in this advisory. You would have to go read up on like 2 or 3 other advisories to get the full picture of like all the details that are happening. But you can get the like overall idea and strategy that they went with here. And it is kind of an interesting bug whenever you have these file system races. It can be really difficult to defend against from like a code perspective. And they even said at one point, like, they tried to suggest not even allowing this rename feature to be in the code because they saw it as like so dangerous originally. But they needed it for what they wanted to do, so they weren't going to do that. And at the time, it wasn't proven to be exploitable. It actually took them some months, maybe even up to a year, to prove that it was exploitable. So yeah, a bit of a tricky chain and some cool tricks in there as well, especially with the app armor bypass and the fuse trick to unmount the future bind mounts.
Yeah, it's
Some cool
def-
stuff I wasn't aware of there.
it's definitely a bit of a complex chain on there. I will say it is fun to kind of see, taking a fairly simple vulnerability of just, those the two CVs they used, to create a directory and being able to use that as like their full app armor bypass. Like, that is something that would usually be seen as a pretty weak primitive to start off with. Is creating this directory, not even control over the name of the directory, but that alone was sufficient to kind of wrap up the exploit. It's just neat to see that. But
Yeah,
on the
and
whole,
it's a
like,
technique I could see borrowed for other exploit chains too, for sure.
yeah, and on the
Um,
whole, these do kind of come down, like the whole race condition file system issues. These are like traditional kind of desktop application issues. I've seen similar things in a lot of just services. Even obviously Snapd is on Linux, but you do see these sorts of races in Windows too. A little bit different because the sim linking is different over on Windows, but ways around that. Either way, or regardless, it is kind of indicative of the types of issues you might want to search for if you are doing kind of the desktop style applications instead of just looking at web bounty.
yeah. So, getting into some more web issues. Next, we have one of our headlining topics, which is an XSS in LegalLegends.com via easyXDM, which is a developer-focused JS library that provides an interface for doing cross-origin communication, and it involves kind of a producer and consumer setup. So, a producer page can export functions that can be invoked by the consumer page. So, it's sort of like RPC on the web, basically. In this case, the producer was the account.legallegends.com/pm page, which exported some various functions, such as like the send function for sending requests and responses cross origin, a get cookies function, and a set cookies function. So obviously, as the author points out, these sound pretty sensitive and useful from an attacker standpoint. So there is some protections to try to make sure that an attacker can't just invoke these, arbitrary functions. Mainly what that's based around is an allow list. So yeah, the document referrer was checked against an allow list of domains owned by Riot Games or their partners. And on top of that, the message origin reported by easyXDM was also checked against that same list. So they started looking at some ways that they could bypass that referrer check. One way they explored was like posting a link on the League of Legends forum, which would match the wildcard LeagueOfLegends.com rule, but it relies on a victim clicking the link. It's not really a great attack vector. They wanted to see if they could find something better. Um, and yeah, so they went looking for something else, and they did find something better through easyXDM, which was an open redirect in frame element transport. So frame element transport is primarily used for passing variables using the frame element property on Gecko browsers. And one of the things it allows you to do is you can set the window top location to this xdm underscore e parameter, which you can control, and it's also known as config remote, which is kind of important for later on. And you can get to that path by specifying the protocol or XDMP to 5, which I believe makes it so the frame element transport is actually used. Now, there is one additional stipulation there that the document referrer has to be set as well, which could be stripped by browsers, especially nowadays. But this was reported back in 2016 or so. It's only recently that they were allowed to disclose it. So at the time, browsers were probably letting that through more than they would be nowadays. So that's kind of relevant for like the exploitability and whatnot. So yeah, they ended up using this Apollo consumer page to pivot to the PM page through Open Redirect. So yeah, they now had Open Redirect and they could bypass the referrer check. But there was still the origin check on the message, so they still needed another bug. The second bug they found was in hash transport, which is used for communicating across iframes through the window location hash. It seems like a bit of a hacky technique, and the problem with that technique is it's not possible for the parent page to know who actually updated the location hash, and so the hash transport just has to assume that all of the messages coming from this or came from the config remote property, which is also attacker controlled. So an attacker can basically just say like, "Hey, these messages came from a trusted origin," by setting the config remote to a trusted domain. The thing is, there's a catch-22 here though, because both the open redirect and the bypass relies on setting that config remote. So they can either set it to an attacker domain to get their malicious page loaded in the open redirect, but then all the messages will be rejected due to not being allowed from an due to not being from an allowed origin. Or they could set the config remote to an allowed origin, but then their web page will never get loaded. So it's a bit of a tricky scenario. So they had to revisit their open redirect bug and revise it with a slightly different path. This time they leveraged hash transport again to basically do some nested frames to get their attacker page loaded under this Apollo consumer in an iframe, which could then change the parent Windows location source back to pm.html to ultimately send messages to pm to invoke methods. And since it proxies through the iframe, it's seen as coming from an allowed origin. This too was a little bit limited because they couldn't receive messages back since they don't have the context of that second level iframe that communicates with PM. So they were able to send requests to it, but they couldn't get responses back. They were blind basically. On top of that, easyXDM tries to sign and verify incoming messages. This at least though is bypassable as well, since they sign using a secret, assuming the attacker doesn't have control of that second level iframe from the start. So an attacker in this case, because they do have control of the iframe from the start, they can just set their own secret and get access to those methods I mentioned earlier. The way they exploit this is they use the ability to make XHR requests to take advantage of a jQuery feature, where if a jQuery request URL ends in equals question mark, it'll try to load it as a JSON P call, and that essentially gives them XSS. It's a bit of like a weird thing with jQuery, where I think it's patched in jQuery v4, but on lower versions, yeah, it just kind of has like that hidden feature or functionality, where it'll try to load it as a JSON-P call if it ends in the equals question mark. I don't know if you've really seen that too much before, Z. I don't think we've seen it in the topics we've covered, but
Yeah, I don't think we've covered it. I mean, Jason P's definitely fallen out of favor in general. It was more common kind of in the earlier days of like Ajax and all of that. Not as common anymore because there are there are some other issues that kind of come from just because the way JCP would work is you'd basically provided like the callback to execute when it's done from a remote origin. It just created a lot of issues. So I don't see a use super often anymore anyhow. That's probably at least part of why jQuery would have phased it out. Or phased
Yeah.
it out where it's just going by the domain. Or
Okay.
sorry,
Makes
by the
sense.
URL.
Makes sense. But yeah, at the time they exploited this, yeah, they were able to get fairly easy XSS abusing that feature. And they can do it blind since they don't need any response. They have XSS already. So yeah, it's a pretty long chain and a winding road of problems to get to the final goal, but putting it all together, they were able to achieve XSS. There is a little bonus snippet towards the end of the post where Riot included a partial mitigation where they updated their Apollo endpoint to check the document refer against the allow list again at the second level. But the researcher found another bypass by using the login auth flow to redirect to the Apollo endpoint. And thus, since you're being redirected from the login auth endpoint, which is going to be in the allow list, they can bypass the allow list check. But yeah, this was a fairly old report back in 2016. It might be one of the oldest like vulnerabilities or attacks that we've covered in that way, though the write-up is new and it is an interesting and pretty complex chain. And it's against League of Legends, the League of Legends site, which is a pretty big game. So yeah, there's some interesting aspects here. It is a bit of a difficult read. You are gonna have to go through yeah, there's like 3 or 4 steps and blockages they had to get around and rework their chain and stuff. Yeah, it was one of the more complex web chains that I'd seen that we've covered on the podcast. So yeah, there's
Yeah,
there's some interesting stuff in here.
definitely a lengthy chain. I appreciate the fact they came back and actually did disclose this. I mean, being from 2016, there's a lot of reasons just think, well, it's too old, don't even bother, especially as a lot of these things aren't even relevant anymore in the sense of like how account.leagueoflegends.com works today. They call that out as like a lot of this isn't even relevant anymore, but still disclosing it so people can see how the exploit worked and going into that. I really appreciate getting that information, even if it's not like the latest bug. It is still an interesting chain to see, and can still inspire ideas for others to follow up on in their own situations.
Yeah. All right, so we'll move into our last topic here, which is our other headlining topic, and is about Hyundai and the fact that it was possible to remotely control the locks, engine, horn, headlights, and trunks of vehicles made after 2012. So this was posted in a Twitter thread by Sam Curry, and Z looked into this a little bit more, so I'll let him take the lead on it. But yeah, I definitely saw this one making the rounds because the impact is pretty interesting.
Yeah, and the issues. It's a pretty fun bug. It's yet another like JWT issue or yet another normalization issue, depending on how you want to look at this. So with Hyundai, you've got their vehicles, you've got this web panel you can use, or I assume most like their apps just use it as an API. Use the app, and it sends an API request to unlock or lock or whatever the vehicle. And what it does with that is for authorization, when you log in, you get a JWT, pretty standard there, and you send that with your as like an access token with your request. The JWT would include the user's email in it. And what was interesting is also when you would make a post request to actually do something. So they have the example here of making an unlock request. It would send in a parameter. So you'd send in the vehicle's VIN, and you'd have a parameter username, which included the same email that already exists in the JWT. I forget if I mentioned that the JWT would include the user's email as one of the claims or whatever inside of there. Just so you can associate this token belongs to this user along with the normal set of or piece of information in there. So they thought it was a little bit weird that you would have to send the email with it when your access token included who you were. But they did notice that if the email you sent didn't match the JWT, it would basically just throw you with an error, like, "Hey, not your user," whatever. I assume it also did the usual like expected checks for does this user own this VIN sort of thing. But the bug they actually ended up finding here was that the JWT's email would effectively get normalized. And in addition to that, registering an account didn't require confirming you actually owned the email. So combining those two, they could register an email address that ended with a carriage return. Have that carriage return character as part of their email that they register with, and that ends up in the JWT as like email with carriage return. But when it does the comparison of the email you're sending in as part of the request body and what's in the JWT, it'll do some normalization there, and it'll see these two emails as being equivalent or equal, despite the fact one of them is definitely different, just because of some normalization going on there. So you could register this example at gmail.com, carriage return email, and then send the unlock request for a vehicle belonging to example at gmail.com without that little trailing carriage return, and it would accept it. That is kind of a pattern I've seen with some APIs before, where you'll have the same information, just like this general pattern of having the same information in two places or repeated and trusting one over the other, or just choosing one of them because you think they're equal. It is the pattern I've seen before, so I'm not super surprised that it's here. At the same time, avoiding having that duplication of information is kind of a way to avoid this. Nonetheless, because it would normalize down this attacker email being something different, normalize into the same thing, you could basically make any request as the victim user, as the user with the normal email address. So a very fun issue. Again, normalization issues are always kind of interesting to see because they just pop up in weird places. But yeah, in this case, so I did mention you had to send the VIN. There's another API request, so you could use this against like more than just that one API request. So you could use this to also list all of the VINs that the account owner held. So you'd be able to expose the VIN that way. You don't have to know it. All you need to know is their email address. And you can register this matching email in order to get access to their account. Yeah, yet another case of JWTs kind of being misused. They're not trusted, doing some normalization. I don't know where I'd want to really set the blame on this one. If I want to say, just trust the info right out the JWT and don't try and be too smart. Or if I'd want to say, just don't do the normalization and the duplication doesn't matter. I'm not sure where I'd really want to put the blame on this one, but it is an interesting bug nonetheless.
Yeah. And of course, it offers some interesting functionality because of what the apps support. Supporting being able to start the vehicle, stop it, unlock it, whatever. Which when you're talking about like multi tens of thousands of dollars vehicles, it's pretty. We've seen car hacking used for stealing them before, so yeah, pretty interesting impact here.
Pretty
Could be
simple
something
for
that
stealing too. Some of the past ones we've
yeah
talked about for stealing have been, I think we talked about one of like the key attacks, which was like a crypto issue and
yeah
very
I
low
remember that
level.
one.
Had that crazy video to go alongside of it, all epic music and everything. Um, but yeah, no, this one's pretty simple. I mean, it's a web or API attack. It's a nice bug. Like I do like this one. And yeah, the damage just because of where it is significant.
Yeah, it's one of those attacks that it could be very practical. Somebody could make like a device or just use their phone or something to like pull this off. So yeah, pretty interesting chain of attacks. Because of how interesting it was, it made the rounds. Now, as far as I know, like this isn't relevant for like the newest models or anything like that. That said, I'm not 100% sure. I don't remember if he goes into that at all. I'm just checking. I don't think he's yeah. So he says we reported it to Hyundai. Yeah, so they've confirmed the fix. So yeah, it's not. It is like fully patched. It's not really going to be used to anymore. But yeah, I mean, pretty interesting attack chain overall.
Yeah, and this is kind of the sort of thing you could apply to other APIs. Maybe not as sensitive as vehicle unlocking, but just when you have that duplication of information, that comparison, one of them gets trusted, you can have this sort of issue come up. And normalization issues. We were talking about them last stream, or last bounty episode too. Uh, Normalization is a problem, and I think it's really hard to kind of wrap your head around all the different things that can happen just when you like lowercase or uppercase something. I don't know if that's what happened here, to be clear. I'm not saying they were specifically like lowercasing and that stripped the new line character, but it's easy. I mean, a lot of developers would just be like, strip a string of like trailing white space because why would I want white space there? And then you can have this sort of issue come up. Um, a lot of times the bugs are, I think, quite a bit less important, but it is still the case of it's still something that happens, and like keep an eye out for it.
Yeah. And Hex ATUL mentions in chat. I mean, people use the same card for almost a decade, though. Yeah, but I believe where this is at, like an API level issue. I think it's fixable. Like it's centralized by Hyundai. Like they can fix this at the API level, and the attack is dead. Like the car model, I don't think matters very much for like the exploitability of the attack, basically.
Yeah, they don't really talk about what the communication between the API and the vehicle looks like. This is between the app and the API where this
Yeah,
issue existed. So there may be some other issues at like that level of communication. Um, but this issue could be fixed.
yeah, I think I misspoke a bit earlier because I mentioned like the latest models or whatever, and I was kind of thinking through it as I was talking about it. So yeah, I totally understand the confusion, but yeah, I believe this is at the API layer, so it's not tied to the specific car models or anything like that. Now, if you found an issue from like the server to the car models, then yeah, that would be a bit more of an issue that wouldn't be as easily fixed, I don't think. So yeah, but yeah, with that said, that's pretty much everything that we have for the episode today. So Z, unless you have anything you want to add on, we'll go ahead and wrap the show up.
Yeah, no shout outs.
All right. So thank you everyone who tuned in. The VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. And we'll be back tomorrow with the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific. And we'll see you then.